Hello, everyone. Welcome to the Carolina Weather Group. This is the Wednesday, September 5th, 2018 edition of our little weather get-together. We're happy to have you joining us tonight as we talk about hurricanes. It certainly has been a active few days in the tropics, and all indications are the activity is going to continue and maybe intensify over the next week or so. So that is the topic tonight. We're going to be talking with Kaitlin Wright, who is a meteorologist at WWEAR in Pensacola, Florida. Kaitlin just had experiences and brushes with Tropical Storm Gordon yesterday. So we're going to talk about the effects that Gordon had along the Gulf Coast. And we also have with us Dr. Jennifer DeHart from the Colorado State University. Jennifer is an expert in how geography features affect hurricanes and how they play an important role in a hurricane strengthening or weakening. So we're going to kind of talk about that as well tonight. And before we do that, this is a live broadcast. So if you want to interact with us throughout the show tonight, we ask you to do that on one of many features of platforms that we have: Facebook Live, Twitter, our YouTube page. You can all send comments if you're watching on those platforms, or you can tweet us at Carolina WX Group. We'll be monitoring all of those tonight, and we'll take any questions or comments that you have for our guests and kind of plug them into the show as we see fit. And towards the end of the show, if you're listening on our podcast, we'll allow our guests to promote their social media platforms and stuff like that. So if you have any questions later on down the road, you can have a way to get in touch with Kaitlin or Jennifer. So with that, we are going to skip kind of the weather roundtable discussion of what's going on in the area. We want to maximize our time with our guests tonight. So I'm going to toss it to Shay Gibson, who is quickly going to give us a recap of what's going on in the tropics. And then Shay will give it to Ricky, because we have Ricky back tonight, and he will kind of moderate our discussion. And as always, all the other panelists will chime in if we need to, and we'll be monitoring for your questions. So with that, I'll give it to Shay. And Shay, I'll let you start.
Thank you very much, Scotty. We have quite an active pattern going on right now. We had Tropical Storm Gordon make landfall last night along the Alabama coast, and it is now depression. The last advisory was 30 miles per hour, pressure at 1,012 millibars. Really, it's more of a rainmaker at this point. If we look at the radar real quick on GRE Earth, there's a lot of moisture still training in along the Florida coast and parts of Alabama and Mississippi. Even New Orleans feeling some of the banding. Very slow moving just north of Jackson, Mississippi right now. It is expected to head off to the northwest in time. The track, I think the last advisory had the track, but not this one. What's most important with this is the rainfall potential coming up in the future. And it looks like we're still looking at half a foot or more for some of these areas moving up into Arkansas, the plains and Midwest, as it wraps around high pressure that is out in the Atlantic right now. A lot of these folks are going to be feeling it. It's also joining along a cold front, so we'll see increased rainfall. Meanwhile, let's go back to the tropics here. We have this wave off of Africa. We have another one coming behind that we're watching as well. And we are right at the peak of the hurricane season. So September the 10th is normally known as the peak of the hurricane season. And so we're seeing a lot of this activity. This is completely normal. And this is the time of year when we start to see an uptick. This disturbance invests 92L. Next one would be 93L. It's a 70% chance, 48 hours, 90% next 5 days. It is expected to head to the west, general direction towards the Windward Leeward Islands in time. So this one may merit watching for these islands, and this one's going to slide a little bit west. Meanwhile, to the northwest of that is Major Hurricane Florence, now a Category 4 hurricane with winds of 130 miles per hour. It's over warm water. There's some upper shear aloft, but it doesn't seem to be doing a lot of damage to the storm. If you look at visible right now, very impressive outflow. You can see the outflow a little bit blocked on the southwestern quadrant. There's a little bit of dry air, a little bit of upper shear, and we can see that upper shear with this upper cirrus clouds really fanning off to the north and to the northeast very quickly. It's going to remain over this area of upper shear, but it could remain a Category 3 or 4 through the next couple of days or so. In fact, the NHC, if we go back to the map, keeps this as a major hurricane at least through Friday, where we could see a tad bit of weakening from that upper shear. And once it moves past some of that area, it becomes major again. Look out for Bermuda here. I think if anybody needs to be watching this storm the most right now, the biggest concern might be for the folks in Bermuda, as this storm could be major by the time Monday rolls around. The general track, the NHC, has been pretty successful in its track to this date. And in fact, they did really good with Gordon as well. So hats off to them, but we also need to watch this track right here. Folks along the East Coast, Southeast, no need to be concerned right now. I think we just need to be watching the storm, tune in regularly to find out what the latest is. If you don't have a hurricane plan, you should have one. Also have your survival kits and evacuation plans in place, because it is the peak of the hurricane season, regardless of whether or not the system comes near the coast or not. Let's go back to actually, one thing I want to do is the sea surface temperature. So Category 4 right now, sea surface temperatures are pretty warm out there. We're looking at the 80s, mainly low to mid 80s. And as it moves to the west and northwest, it's going to move over generally warmer water. In fact, sea surface temperatures where Florence is right now are about 27 to 28 degrees Celsius. That's going to move towards the 29 and 30 degree waters out here. This is not going to be exact in some of these areas. I think the warmer waters are mainly right between 84 and 88 degrees. The depth of the warm water has yet to be known, but the buoys do pick up on it. So that's where we start talking about the tropical cyclone heat potential. Florence is moving into an area of more conducive surface fueling. This map basically is showing the sea surface temperatures warmer, and not only warmer, but deeper. And so the heat potential generally starts at about 20 kilojoules per centimeter squared is the magic number, and it's moving well in above that number. So the surface fueling for the storm, that's why they're keeping it a major hurricane. Looking at Weather Nerd's site, I got this from Mike Boylan's page, Mike's weather page. The Euro ensemble, now we can't start getting confused too far out in time, and everyone's looking at these deterministic runs one at a time, and each run, well, they're kind of all over the map too as to whether or not we're going to see this come close to the United States. The Euro tends to jog a little further west with the majority of the models, but that can change. This is way far out in time. We don't need to be we need to be very skeptical about these right now and not take anything for granted or say that, you know, any one of these points, look at the spread anywhere from South Florida all the way up to Nova Scotia. So anywhere in there is fair game as far as the system, but it may just curve out to sea either way. The GFS ensemble over here, the majority of the models keeping this curved out off of the coast. So, you know, these runs are just, you know, they're basically one to the other. Here's the deterministic run. The main factor here, as we run into time, the GFS, Bermuda being dangerously close to the system on both the Euro and the GFS. Those are the main concerns right now. And then we have this ridge building off the East Coast, Northeast Coast, United States. This may be the deciding factor whether or not the system may be a problem for the coast, but it's still too early to determine. Even the Euro has that same ridge at the same time by Tuesday next week as being over the top. This tends to be a blocking mechanism, and it sends the systems a little bit further to the west. How strong that ridge builds has yet to be determined. So there's no need to be alarmed yet for anybody on the coastline. We're just watching. We're watching each run of all of these models, not just these deterministic, but all the members of the run, which are hundreds of them. So if anyone's concerned about it right now, don't be. Just be watching and tuning in. Back to you. Actually, not back to you, Scotty, but over to Ricky.
All righty. Thank you very much, Shay. Nice detailed analysis there. It's kind of another tropical system right on the heels of what we just got done dealing with Gordon, and it seemed like Florence kind of got hidden for a couple of days by Gordon making such a close approach and then landfall in the United States. Kaitlin, nice to have you on tonight. Nice to see you again. Hope everything's well down in Pensacola, and hope you guys survived the storm well. I know you guys had at least one death that I heard of, but for the most part, it seemed like a pretty quick-moving storm that came through during the overnight hours and then quickly moved out.
Yeah, it moved out rather quickly, but one thing, first, let's go ahead and get to that death. We do have one reported fatality, and it was actually a young child. A tree fell on a mobile home, and that child died. So that's just so sad. We don't have any information right now as to how old that child was, but it was a child nonetheless. Doesn't matter. It's still death. So a lot of people, say, oh, it was just a tropical storm, or we're not worried. We're not going to have a plan. We're not going to have preparations. But this is just one instance, and it really goes to show you that it's a tropical storm you have to take seriously. So it did move out fast for most of the area. The winds really calmed down rather quickly once the system, once the low just moved through Mississippi. Our winds calmed down fairly quickly. But I don't know if I can. But we're still seeing rain bands. We are still right now, and that's again 24 hours later, more than 20, or just about 24 hours later, maybe 30. But we've seen quite a bit of rain, almost 11 inches in some areas.
And that amount of rain, does that cause serious flooding issues in the Pensacola area, or does it all kind of soak in that nice tropical Florida soil?
No, not so much the latter half. So we have some roads like Fort Pickens Road that's 6 inches above sea level. And so it is very low lying here for most of the area. And it's a pretty old area. So we have older trees, and we have had a lot of rain the last couple of weeks. And so the grounds are already very saturated. And so we have a lot of down trees right now. So that water didn't just soak up into the soil. It's kind of on top. We have some just ponding on the roadways, but most certainly those low-lying areas and those poor drainage areas, we've seen quite a bit of flooding.
Talk about just Pensacola. For people who don't know, Kaitlin is at WEAR in Pensacola. Talk about how the area just kind of deals with tropical storms and hurricanes. I know Ivan was the big one back in 2004. Is that still the baseline? What kind of bases everything off of?
Yeah, I think so. I think for people that were here during Ivan, have a new look on tropical systems, and they know the damage that it can do. So we, last year kind of had 2 glancing blows with Irma going to our east and then Harvey going to our west. So I think people in Pensacola do well with preparation. And WEAR, the ABC station I work for here, is the only station in Northwest Florida. And then our other stations is kind of a hybrid market. So we have stations in Mobile, and that's where the National Weather Service is out of as well. So in terms of preparations for the news station, it's just all hands on deck. And for the community, we have our DOT workers, our emergency management. They all do very well with preparing for storms like this. Since we are along the coast, and since we did see a storm like Ivan, they have learned a lot and been through kind of trial and error with a couple of storms. But they even put sandbags out for this tropical storm through 2 counties. Not a lot of people used them. Didn't see a lot of places boarded up when the wind really wasn't our primary threat. It was the flooding.
Kaitlin, I got a question for you. How did the storm surge verify in your neck of the woods? Was there? I don't think there was as much of a threat to Pensacola as there was to maybe like Mississippi coast. But how was the surge? Did it cause significant flooding in your neck of the woods?
I would say areas toward the coast. It did. I think our surge ended up being just about 2 feet. So we were forecasting around 2 to 4 feet and 3 to 5 in Mobile County. So that's the last most western county there. There's only Mobile and Baldwin County in Alabama toward the coast. It's small. And then in Mississippi as well. So Dauphin Island, Fort Pickens, areas that are just very low lying and that see flooding if they, have a strong thunderstorm roll through. Those are areas that most certainly saw quite a bit of rain and surge from that.
Yeah, some of those areas got lucky. I saw Mobile Bay. There was 50 to 60 mile an hour winds, but they were offshore, northwest. So that actually maybe helped keep the, some of the water down a little bit, blowing it out instead of in. So that I think that helped in a lot of areas about offshore wind.
Yeah, I totally agree with that. And just the timing too. It was not peak high tide. So that definitely helped as well. Fort Morgan is the area that saw, as of now, the reported highest wind gust, which was 78 miles per hour. And then Dauphin Island, that area I'm talking, it's just a small little sliver of land just off the coast of Mobile County in Alabama, saw 74 mile per hour winds, and in Pensacola, 61 miles per hour. So the winds were kind of in and out, really, as we're talking. The surge affected some coastal areas. We've put a lot of money into Fort Pickens Road here in Pensacola, and we actually just were discussing this last week on our news that we don't know if we're going to keep on funding that road. I mean, every time a storm comes and more than a half a foot surge comes, it just wipes out the road. And that's a big camping base here in Northwest Florida. So a lot of campers and visitors are pretty upset about that.
Yeah, we had some spots here along our coastline like that as well. We just let it go. Had to let it go.
Yeah, just not meant to be.
So, Kaitlin, it's obviously the hardest summer. Well, I guess it was Labor Day, so many people are going back to school, but still, Florida's a pretty active time throughout the entire warm summer months. Talk about people from out of town. Do you guys have a bunch of out of town people this time of the year, and how did any of them fare?
Like you said, Labor Day is kind of the cutoff. So Labor Day weekend, it was packed here in Pensacola, and our viewing area includes Fort Walton Beach and Destin, which are very populated areas. I like that you raised the point about vacationers, because we stressed a lot the rip current risk, because we have more people die in rip currents than we do anything else in Northwest Florida. We've had several deaths this summer from rip currents. So we're trying to get that out. We actually had a tornado warning that I was on air for at 2:50, 3 o'clock this morning in Destin, which is a very populated area, and a lot of people have vacation homes there. So we're just trying to warn vacationers for the storm. The good news is, if there is good news in this situation, that it was after Labor Day, and it wasn't during the week, over the weekend when all those vacationers were here.
I saw interesting, I don't remember where it was, one of your social media posts last night talking about, it looked like the center was here, but the center was actually a little bit further to the west. Interesting structure on this storm.
Very interesting. I was looking at a sounding. I could not figure out why the National Hurricane Center during that last update did not shift the cone. Because I'm like, this is either hitting Pensacola direct on, because it looked like it was just moving to the north, or hitting southwest Alabama. But I was looking at the sounding, and the low level winds were just much faster than the upper level winds. And so it was actually equating to westerly wind shear. And that's why it was a very tilted system. It looked like it was moving directly to the north, but it had a northwesterly component. I'm still pretty shocked. In National Hurricane's last cone, they had the area that it made landfall, just the very eastern side, almost that eastern line of the cone, since it ended up making landfall kind of in between Pascagoula and Mississippi and Bayou La Batre in Mobile County, right along the coast, or right along the state line.
Yeah, I remember the NAM 3 was kind of seeing that a little bit as well. A little bit more of an easterly jog to it. Interesting stuff.
Yeah, very interesting.
And you mentioned how a lot of the areas along those places are pretty low lying. What is the biggest threat from a tropical system? Is it surge for you guys, or is it rain? Or for a tropical storm like this, what would the biggest impact be?
I think it depends on our previous weather. Of course, in this instance and in this situation, it was rain because our grounds were already very saturated. Storm surge is always a threat, of course, depending on the angle of approach that the storm's coming. So we always look out for those two things. But I would have to go, and then I don't know. It's kind of all a toss-up. I think they're all kind of equal, especially rip currents. We have a lot of vacationers here that just don't know how to swim out of a rip current. If you're from the north, maybe Ohio, and this is your first time here, maybe you don't know. I know before I really started studying it, I wouldn't know to swim parallel to the shore to get out of the rip current and just stay calm. And so I think rip currents are probably the number one thing. Surge and rain, yes. But some people, we have red flags flying. Single red flags mean surfers can go in to the Gulf of Mexico. Double red flags mean that it's closed to everybody. So some people just think that they can do it, even if they're experienced swimmers and can't. So that's a pretty big threat and concern.
Did you hear that, Shay? No swimming along the Pensacola coast next time there's a tropical storm.
Yeah, I'll tell my kite friend buddies in Fort Walton for sure. They won't listen.
I know they won't.
All righty, y'all. Any other further questions? I think we're going to jump to our next topic here. I'll take that as a no. All right. Well, Kaitlin, thank you so much for joining us. You're welcome to stick around, or if you need to jump off, I know you got to do the morning show, and I'm sure you're still a little bit tired. I got to go back and watch your tornado coverage. I'm going to go pull it from the Sinclair archives here in a little bit. So
you can do just that.
All right. Well, thanks again for joining us, and we're going to switch over topics here just a little bit, kind of still involving Pensacola and the coastlines. Dr. Jen, I forgot your last name. I'm sorry. Jen is joining us here. Dr. Jen, let's call you that. I like that. talking about kind of how coastlines and geography and everything can impact storms and impact the strength of storms. Welcome to the show.
Thank you. Thank you for having me.
So we might as well just hit it right on the nose for the start. Anything interesting with Gordon that kind of popped off to you?
Yeah, so my research focus was specifically more about mountainous terrain. So it's a little bit flatter in that area, but nothing has stood out so far. But I mean, beyond just how slow it's been moving and just the how stalled it's been for the most part and just really drenching the area. So yeah.
Gotcha. So, I mean, with mountains and influences of tropical cyclones, we get that a ton here in North Carolina, especially on the eastern side. As Scotty will tell you, it seems like Scotty floods away every single time a tropical storm comes up into our area. Talk about just some of the basic aspects of how mountains can impact tropical cyclones.
Right. So it's still an active area of research, definitely, but there's many different ways that can occur. First and foremost, I mean, when we think about orographic modification of any type of precip, we always think enhanced rain, simply because you get more lift, you get more condensation, and that cloud droplets can be picked up by the rain and fall. So at the basic level, that's kind of what we think of when we think of any cloud interacting with a mountain. But for hurricanes as well, places like Taiwan, in particular, other mountainous islands will often see really intense rainfall, particularly up in the high mountains, which can lead to landslides. So it's definitely a kind of public health issue to be dealt with. But the other thing, and this was kind of what I dealt with in my PhD, was if you have a large continental-sized mountain range. So, for instance, my dissertation was focusing on Mexico, specifically the state of Veracruz. There was Hurricane Carl in 2010 made landfall there. It's so big, that mountain range, that when the storm or a hurricane moves over the terrain, hurricanes are rather fragile beings. They get easily ripped apart by shear. So it actually can really weaken the strength of the circulation pretty rapidly. So you have this competing influence of, well, you might have enhanced rainfall, but you can also lead to much more rapid weakening of a storm simply because you're disrupting the circulation, you're introducing dry air, et cetera. So there's kind of all of these different ways. And when we think of a hurricane, we often think of moist neutral for the people that know what that means. But so essentially really moist, low static stability, so easy to lift, parcel up. But obviously within a hurricane, you have very different thermodynamic regions where you're going to have different stability in the eye versus the eye wall versus the outer bands, where you might have more convective potential. And so we wouldn't necessarily expect a parcel in each of those regions to respond the same. So another thing I found in some research was, there could be more convective than we initially thought, or different processes can occur in different regions. So it's a really complex topic, and it's certainly a continued area of research, but there's a lot of interesting stuff being done. And that's just like broad scale, not even getting into the small scale microphysics. So quite a bit. And it also depends too, like distance from the coast. So in the East Coast, obviously the mountains are a bit further inland than like in Taiwan or even in eastern Mexico. So you could already have some weakening occurring simply due to the fact that it takes more time to move inland. So it really is highly variable based on your geographic region and the underlying topography that exists.
How about all the islands? It seems like every single tropical season we talk about a system moving over Hispaniola or moving over Puerto Rico and the impact those mountains may have on it. And it seems to vary storm per storm how much they're impacted. Have you looked at any of that, or have any thoughts on just kind of how some of those islands can impact systems?
Yeah, so I haven't directly looked at it, but just looking at prior research that's been done, it really depends partially on the storm track and where the center of the storm is. So you, similar to what you have over continental mountain range, if your inner core, so your eye or your eye wall goes over the mountainous terrain, you can still have that similar disruption and decay that occurs simply from moving over the mountainous terrain. However, if the mountain is or the island is further removed from the center, you are not going to have that disruption. It's not really going to affect the core, and you can just continue like pumping in this moisture and this rainfall to really affect it. So it really depends case by case on the track of the storm, the distance relative to the terrain, as well as the size of the mountainous island, like how tall it is, how wide it is. It really varies based on each storm. So quite a bit that goes on. I forget. I think Maria got slightly disrupted when it went over Puerto Rico, but if I recall, it didn't entirely decay. It kind of moved past and then continued.
Hey, Jen, we saw this with Irma, with the interaction with Cuba. Could you talk a little bit about that?
Yeah, well, in the case of Cuba, from what I recall, that was it. It kind of kept the intensity down, if I recall correctly. Like the models were kind of having it continue to be a bit stronger, and the terrain, obviously to the detriment of the people in Cuba, because it hugged the terrain, it actually kept the intensity down a little bit, and similar to what I was saying before. And so when it kind of finally emerged, it wasn't as strong as they were initially anticipating. I think they also, I mean, anytime you have a hurricane, it's going to be a really big rainmaker. You add mountains that can really enhance that as well. So yeah, I remember that the intensity aspect was really fascinating, and I think it was a bit further inland than the models had initially thought. So yeah.
Okay, well, I'll go ahead with one. We talked a little bit before the show about hurricanes like Hurricane Hugo in 1989, where you get a direct beeline of a storm right into a coastal plain that heads slowly upslope towards the Midlands and up to the upstates. And we saw the damaging effects it had from Columbia all the way inland to Greenville and up into North Carolina, Charlotte, on over to the mountainous zone. So if you'd like to talk a little bit about that, I'm all ears. I'm sure a lot of us in the Carolina Weather Grid would love to hear your takes on that.
Yeah, so I don't remember the exact details of Hugo, but especially if it's a more gentle slope, you're obviously, anytime you move over land, the storm will weaken somewhat, or begin to weaken, but it could actually, you don't actually need a huge slope to feel the effects of topography in terms of the rainfall, which is my main focus. So even a slight incline, I mean, they've seen enhanced rainfall on the top of 500-meter mountains or slopes. So moving inland, that could certainly be a contributor. And yeah, it's for each case, it's such a complicated interplay of the specific track and what that and the geometry of the flow and where the storm is going. But yeah, I must admit, I'm not terribly familiar with that particular case because I focused on this one particular storm. But yeah, it would be there's that balance between the destruction of the hurricane as well as this upslope enhancement of the rainfall and the relative contributions. Because once you destroy the storm, you might see less rainfall, which is what I actually saw in my dissertation. So it'd be interesting for me to go back and look at that case and see exactly what the rainfall pattern looked like, as well as how rapidly or not rapidly it was weakening as that was occurring. I definitely need to go back and look into that. So.
No, I appreciate that. I mean, I know you do in-depth studies on certain systems and everything. It's sort of like I don't know why I've always felt that after being here and experiencing hurricanes in the South Carolina area along the coastal South Carolina, you tend to see like, especially storms coming up from the south across the Florida Panhandle up just lee side of the Appalachian Mountains, where you get the downsloping effects. And it seems like your onshore winds are not as much of a punch inland as the downslope winds wrapping around the storm. And that you tend to see more damage. We saw that with Matthew. We saw that with, what was the storm that came up through Florida? Again, I'm drawing a blank on that one a couple years back. But throughout the day, not many power outages. Everything was fine. Lots of rainfall, though, so that is to be accounted for with soil content. But as the storm wraparound flow came, the winds were actually a little bit stronger, and there was more power outages and more damages done from those downslope winds.
Yeah, man, it gets so complicated. Yeah, because as you were saying too, if you have this downslope flow, what effect, or it might inhibit the ability for your kind of onshore flow to come in. The mountain part is super complicated, but yeah, it could be similar to again, I don't know the exact details, but it could be similar to what we see in Colorado with those. Obviously, we have much more intense mountains here, but you get those really sharp downslope flow, and that's due to the upstream stability, the wind speed, and what happens as it approaches that crest. So that is interesting that, yeah, you saw the more intense wind from the downslope flow, but it's probably, I would imagine, pretty similar to what we see here along the Front Range when we get those really strong downslope wind events. But yeah, it can, yeah, it's just interesting how that all connects. So
that was Hermine. Hermine is what I was thinking.
Okay.
Yep. Prime example.
Giving all these great cases because I'm so focused on the really tall mountains that I often neglect the East Coast.
Yeah, storm entrance matters, where it comes from, which direction it's coming from, all that stuff. So, Ricky, did you have a question? Or anybody else have a question?
I got one.
No, go ahead.
Sorry, I was just going to ask if you saw anything, with Hawaii the last couple of weeks with Norman and stuff.
Yeah, so Hawaii just got hit by Lane.
Yeah, Lane and Norman. Sorry.
No. So I actually wasn't able to follow it in real time because I was at a wedding for 2 meteorologists. But I've downloaded, actually just this week, I've been downloading some of the rain gauge data as well as some of the radar data, and that's something I hope to look at soon. But yeah, that's another one of those instances where it'd probably be more similar to Taiwan, of a storm moving near Taiwan, because the core never actually hit the island. So you're actually, that was partially what led to that intense rainfall, was you were able to keep the core away from the islands, just pump that moisture, pump that rain in. And I think similar to Harvey in somewhat, there was kind of like a band that just kind of set up and sat there pumping in, especially on the east side of the Big Island, as well as, is it Maui? Because I think those two islands got the most rainfall. But yeah, it was, again, the storm center was far away from it, just pumping all this moisture in. So by having the train far away, you can have these really remote impacts from the storm. But yeah, that's definitely in a case I'm looking at actively right now. I want to look more at the radar data and see some of the dual pole characteristics of what was occurring microphysically. But yeah, it was pretty similar. Similar to another case too that occurred in Dominica. There was a paper about that, again, where the storm remained far away and ended up dumping like several inches or tons of inches of rainfall. So yeah, I saw that case as it was happening and was immediately intrigued by it, scientifically at least. So if that answered your question, I'm not sure if it did.
Oh, absolutely. Between that and, the 2015 event we had here, South Carolina, North Carolina with, Hurricane Joaquin, as is out in the Bahamas, dumped upwards 14 to 20 inches of rain in parts of South Carolina and North Carolina. I don't know if you've done any research with that, but just curious what your thoughts were.
Yeah, I think wasn't Joaquin partially what they call a pre-event. It's ahead of a hurricane. Again, you have this strong moisture transport.
It was a trifecta situation there.
Right.
It really was.
Yeah.
That was a 3-part. You had a cold front, you had an upper low, and then you had Joaquin, and the fire hose aimed right over us. That was intense. We'll have to have Rob Fowler on to talk about that one with us again. Yeah,
and that's a good example of, you don't actually need mountains to get really intense rainfall from a hurricane. I mean, hurricanes themselves are really efficient rain makers, and especially if they stall, and if you have, again, these other factors that give you extra lift, can really be efficient with that tropical moisture. So yeah, I haven't looked at that case specifically, but I do remember Joaquin, especially with the track uncertainty a couple of days out leading, it was kind of a mess in terms of the forecast.
It was incredible. The rainfall rates were just insane.
What were the
between midnight and probably 5 to 6 a.m., there were probably a lot of places that got close to 10 inches of rain in just 6 hours.
Yeah, that's really intense.
Is there an area that tends to see more heavy rainfall events in tropical cyclones? Is it, the areas of the Western Pacific where they get typhoons, or areas of Mexico where we get these Atlantic cyclones moving through? And is there a reason for that?
Yeah, so I would say, simply based on the number of cyclones, Westpac, Taiwan is definitely one of the hot spots. They're constantly, I think they just had a typhoon 2 weeks ago that set a record, breaking a record from a couple years ago. Because I think they average about 4 typhoons a year, just going over the island itself. So they definitely see the most in terms of this orographic influence, which is why a lot of the research has been done on islands and not necessarily like continental ranges. There's also the island La Reunion. So even further in the Indian Ocean, La Reunion actually has, I think, most of the rainfall records globally. I actually have, I can actually pull up those numbers. I have my defense here. Yeah, so it holds, Lower Union Island holds the 12-hour, 24-hour, 72-hour, and 96-hour rainfall records. And those come from 2 tropical cyclones, respectively, one in 96 and one in 2007. And like, so 12 hours is 1,200 millimeters. I could try and convert that in my head. 24 hours is 1,800 millimeters. 72 hours is 30, like almost 4,000 millimeters. So like meters of rain falling in these short time periods. And that absolutely puts everything we've seen in the US to shame, even a lot of the Taiwan. And these rainfall records are from the top of a crater. So it's right on the top of the mountain. And again, the island's pretty small. So oftentimes it's these hurricanes that are bypassing it from far away. So those are definitely the places that get the most, I would say, in terms of that orographic enhancement.
That'll be part of your thesis defense in the future for another one. You'll have to sit there and try to convert all the milliliters over all the time. So
yeah.
When we see a lot of these systems coming into Mexico, one of the big things you always hear about is a threat for landslides and mudslides. Is just kind of the slope of the mountain chain there one of the factors that comes into it?
Yeah. On both sides, it's pretty, I don't know if I have a good image I could show. I could try sharing my screen. Does that work?
Yeah, that works.
Yeah, so this is from my PhD defense. So this is at least eastern Mexico, showing this is Hurricane Carl's track from 2010. And this is showing the eastern side of the topography. So yeah, it's on the west side, I think it's a bit more intense of a slope, but even on this east side, you have this pretty strong, these greens are less than 500 meters. And this orange here is between 2 and 3 kilometers. That's pretty intense gradient, at least locally. And on the west side, it's even stronger. So yeah, definitely the geography is going to play into the landslide threat. And I know in the case of Hurricane Carl, they had similar to what Kaitlin was talking about earlier, they had a really wet summer before Carl made landfall. So the rainfall itself was nowhere near record breaking, especially compared to what we see in Taiwan or in the Lower Union Island that I mentioned. But it was on top of this already saturated soil that was the bulk of the damage, not necessarily winds, but yeah, the landslides and rainfall threat. So yeah.
When we look at the amounts of rain from tropical cyclones and trying to estimate it, I saw there you got some airborne research. Obviously, probably a lot of these areas, these islands and mountain chains, probably have very sparse radar data available. So what are the primary methods besides rain gauges, kind of going back and looking at the analysis?
Yeah, so that was really challenging in Mexico, just because they had loss of data. They don't have as many stations. So it's really dependent regionally. So Mexico obviously didn't have as many stations as we would like. And another issue is that for like our type of work, we often want pretty high resolution, so every hour, and that might not always be what's given in like the NCDC website or database. Taiwan actually has really great data coverage. They have a ton of rain gauges. They have disdrometers, I think, that are operational to look at drop distributions, so the size of the drops. And they actually have really quite good radar coverage in Taiwan. It's probably the best instrumented site in the world, at least over that small area. But oftentimes it actually is radar that's used just because you can cover so much larger an area, because even rain gauges are going to struggle because they are point sources. It might not necessarily, depending on how big a convective cell is, might not be representative of what's happening 2 miles away. So radar is often used, at least from a kind of first glance and basic overview of what's happened in an event. So in places where you don't have that, then yeah, you're kind of, you have what you have. So it can make it a challenge in certain areas, but at least the US has pretty decent coverage, both in terms of rain gauges, but then also the dual pole network, especially in the hurricane prone areas, is great coverage. So those dual pole drive products are likely what are often what's used to look at that from a kind of larger scale. But there's always research programs that are trying to be funded to have higher quality radar data than what you get with the 88Ds. And add additional instrumentation, soundings, station data, etc. So, yeah.
Are Taiwan's radars dual pol? Do you happen to remember?
It's a mix. So some of them are, and some of them are not.
Okay.
I think at least 2 are dual pol, like one on each side of the island. So, but again, you can't change your scanning strategy based on, it's like we have the operational scanning strategy as you would have here in the US. So can't really do much. So yeah, that's why you need field campaigners to be able to do more specific radar scan strategies.
Well, as we approach 9 o'clock, I've got one more question for me, and then I'll open up the floor for everyone else. Is there, if you could kind of write the book on the perfect storm that would create, the heaviest setup for geography-induced hurricanes, what would that be? Would it be a small storm, a big storm? Would it be a steep slope, a kind of a gentle slope? What is the perfect storm when it comes to heavy rain, tropical cyclones?
I would probably say, I'm not sure that size. Well, I guess the size would only come into impact in terms of how broad you wanted that rainfall to be. But in terms of like kind of a locally heavy rainfall, you would probably want something like an island, because then you could maintain the core of the storm. You could maintain the strength, keep those winds going. I say this as if it's a good thing. In like removing it from the terrain. And you'd probably, for the heaviest rain, you'd want a decent slope, but you wouldn't necessarily want like a cliff, because what you need for the heavy rainfall is for the parcels to move up over the terrain, and that's dependent both on the wind speed, the height of the mountain, as well as the stability. So you'd probably want a more moderate slope, because oftentimes the heaviest rainfall doesn't always occur at the peak height. It can occur on the windward slopes often. So probably a weak to moderate slope. So yeah, keeping the hurricane far from an island of some size, and then having a moderately slope. So maybe 1 to 2 kilometers height would be good conditions for the heavy rainfall. Obviously that wouldn't be good for the people living there, but yeah.
I lied. One more question, and this may make sense. It may not. I'm just thinking in my head, different types of upslope and everything. So would the strength of the upslope matter in terms of like the winds and how fast it's being upslope vected?
Yep. So yeah, so the ability for a parcel to travel over terrain is tied to both, the terrain height as well as the speed of the wind. The stronger the wind, the more easily a parcel, given favorable stability. So given that it can rise up, the wind speed, they're both important. You need the stronger the wind speed and the lower the terrain, the easier it is for air to flow up and over a mountain. So if it's really high, you might get blocking where it goes around the terrain. So
in theory, perhaps a tropical depression with weaker winds would have lesser amounts than a stronger storm?
So it would, in that case, it would depend then. So I'm thinking of the Froude number, which is U over NH. So if the wind speed was weaker, if you were still in a moist neutral or a neutral stability, so there wasn't any kind of inhibition, you could still, the wind speed would be less of a factor. And it doesn't necessarily have to be a surface parcel either. You could have like parcels higher aloft that are being lifted. Because oftentimes there's been cases of tropical storms interacting near terrain that can also produce really heavy rainfall, because in a hurricane, you're not that stable. You're pretty moist and close to neutral. So I wouldn't necessarily say that's the case. You would probably often get really heavy rainfall, even with a tropical storm, simply because the stability would still be in your favor.
Gotcha. All righty. Well, we appreciate you joining us tonight. Any other questions from the panel here? If not, we'll give you an opportunity to plug your social media. We're going to have you back on once you decide to dive into Hurricane Hugo and some of our other rainfall events in the Carolinas. That's going to be your next task. We're going to put you, we can't offer much research money, but we can at least offer, like a bag of cookies or something mailed to you.
No, it's cool. I'm glad you guys brought those up. I'll have to look into those more closely going forward.
Is there a way people can follow you or follow your work?
I have a Twitter account. It's JC DeHart, DEHART. sometimes there's storms and other times there's random thoughts. So that's usually where things get posted. I eventually will make a website, but I don't have one yet for like my research stuff. But yeah, that's usually where I engage in weather Twitter.
Gotcha. And has your thesis been posted yet, or is it still?
Oh yes. Yeah, my dissertation is online somewhere. I think it might be on my old advisor's website at UW, but I don't actually know where to find the thesis. I tried to
work, and now you just want to forget about it for a while.
Yeah, but the first paper for my thesis is published. It was in Monthly Weather Review, and then the second paper I need to publish soon because it's been a year, and that will probably go in a similar journal. But yeah, my thesis is online. I forget what it's called. It's orographic modification, tropical cyclone. You can search my name; it'll probably come up. So
very cool. The wonderful world of Google will help us out eventually.
Yeah.
So, all right. Well, thank you so much for joining us. I'll pass it back over to Scotty. Scotty, you can kind of do some of the old schematics here as we wrap up the show. And once again, thanks for joining us.
Thank you.
Thank you for that, Jen. We appreciate that. And thank you, Ricky. We are wanting to kind of do a quick recap of the tropics for those who may have not been able to tune in at the beginning of the show. I know a lot of you are watching on Facebook Live and Periscope. I think this is probably going to be one of the highest numbers that we've reached. So good, I guess, on that front, but not good for the tropics. So Shay, I'll give it to you. I will say we just got this question in our Facebook inbox, and maybe you can answer it and lead into your discussion. Ulysses Ruse is wanting to know, are we going to be hit here in the Carolinas by Florence? So I'll let you answer that and kind of go into what's going on in the tropics show.
Okay, well, I appreciate the question. Thank you, Scotty. And the answer to that question right now is we just don't know. It's too far in the future to be concerned about it right now. There's a lot of factors, a lot of steering mechanism as it gets towards Bermuda in time. And I'm going to go ahead and do some screen share, and we'll talk a little bit about this. Let me know when you can see it, guys. Everyone good?
Yep,
I got it, Shay.
Okay. So Hurricane Florence, our first major hurricane of the 2018 season, winds up to 130 miles per hour, Category 4, 953 millibars. It underwent rapid intensification since yesterday, so the storm really blew up, which tells us that there's a lot of warmth at the surface. There's a lot of fueling mechanism for the system. Even though it is underneath an area of upper shear, it's still holding as a very strong hurricane. Look at the water vapor imagery, the shortwave infrared imagery as we go from daytime to nighttime. We see a very healthy system with a solid eye. We see the outflow as well, the radial outflow occurring, which means it has healthy outflow aloft. So the exhaust system over the top is very healthy. The one thing that we are seeing is upper shear, which the NHC initially believed might be an inhibitor of convection and an inhibitor of strengthening for the system, but it being a little bit more compact and smaller in size allowed it to grow more. We're still seeing on the southwestern western quadrant of the system, or even the southern quadrant, a little bit of dry air, a little bit of shear blocking that outflow to that direction. But if you look to the north and the northeast, you see this explosion of convection, really all the cirrus tops really flaring off to the north really quick, and that's because of that upper shear line. Looking at the sea surface temperatures, very warm out there. We're in the 80s. It's somewhere between 83 and 88 degrees overall. It's going to be heading towards warmer waters. It's actually over favorable waters. 82.4 degrees is sort of the magic number. 84.2, I'm sorry, not 82.4. And as it heads to the west-northwest, it's going to be moving over an even warmer body of water, which is why the NHC keeps this as a major hurricane going through Friday. Maybe a little bit of a weakening phase due to upper shear and maybe a little bit of ingestion of dry air. But then as it goes to the west, it is expected to re-intensify again because of the warmer waters below and possibly it getting out from underneath the upper shear loft. So this is the basic track. Beyond this NHC track that we see, we don't want to speculate too much about whether or not this is going to be a coastal hit or not. It just means that we don't want to get too far past this. Model runs get very erroneous after 3 to 5 days out. It's too much to say that we're going to be looking at a coastal hit. Sea surface temperatures, once again, we see where Florence is right about here, moving towards the warmer water. We'll look at the European model run from today. There's going to be another one tonight. We're watching these very closely. This is just one deterministic run, so we can't take this at face value. We see Florence moving towards the Bahamas with the blue circle right here. This is the 500 millibar plot, and this is what we're going to be looking at a lot, because as it gets towards Bermuda, and those folks in Bermuda really need to be watching this, this red right here represents a ridge, and this is clockwise motion around the ridge. We tend to get a little bit more of a westerly steer with systems that are underneath ridges because the general steering flow is in that direction. The big question is, the latitude of the storm, will it be able to get picked up by this trough here in the Atlantic or not? It looks like a lot of the models are keeping it a little bit south of that, but we do see that trough pinching off to an upper low in time. And if the ridge breaks down, it may be enough to pull it away from the coastline. The Euro solution to this has the ridge holding a little bit stronger, but that's not to be concerned because these models have been flip-flopping back and forth on the coast or off the coast, swinging out to sea. Majority of the ensembles right now are sort of pulling it out to sea, but we're just not entirely sure of that yet. If we look at the GFS, we see it coming in. This is by Monday next week towards Bermuda. The ridge is there, but then the ridge breaks down, and then we see sort of a transition now. The GFS earlier really pulled this out to sea, but if it slips down over Bermuda, that might push into the coastline. It's just too early to tell. Really, when we get this far out, we shouldn't really be speculating whether or not a coastal hit. What we need to do is focus on this map right here and where it's going to be on Monday. So as we get into the weekend, we'll probably have a much better idea of what's going on. Here's another couple of examples. Let me zoom in here. This is from weathernerds.org. I got this from Mike Boylan on Mike's weather page. If you haven't followed his page, give it a go. And see the Euro ensemble right here from today. And all these members within the model here are majority of them are keeping them off the coastline and curving out to sea. There are some outliers, so you can see the possibilities range anywhere from South Florida all the way up towards Nova Scotia. That's the range right now, and that doesn't even mean that it's going to hit the United States, but we can't pinpoint where or if at this point. Even the GFS, the GEFS ensemble, the majority of them keep it out to sea, and that's of right now. But we're going to be watching these models run to run. There's no need to be of concern right now. I don't think we need to really go beyond this map right here. I think everybody should just be watching, just tune in, make sure that you're checking with your local meteorologist and get the facts. Don't be looking at articles that are blowing up headlines like the Carolina coast will be hit or Outer Banks is going to be hit or whatever news feed is coming through. There's a lot of sort of bad information out there, and we don't want to. Yeah, I know Jared says fake news, but a lot of it, some of it is fake news, absolutely. And Brad Panovich did a really good blog earlier. If you haven't looked him up. He's out of Charlotte. It's great. Did a great blog. And so we don't want to buy into these articles just yet. It's too much time, too many factors to even think about a coastal hit right now. Nothing to be concerned about, but just be watching and tuning in to your local meteorologist. If you don't have a hurricane plan in place, you should always, especially in the hurricane season being at the peak, which is September the 10th. This is normal activity to see an uptick in a spike in activity towards September the 10th. And even down into October, we keep the hurricane possibilities wide open. I think make sure you have your survival kit, an evacuation plan, have all that stuff in place, because you never know. If it's not Florence, maybe it's going to be another one in a week or two. We don't know. There's a lot of systems that have spawned off the African coast. Next one in line, I'll go ahead and share screen one more time because I didn't talk about this one, Invest 92L. And this one has a 70% chance next 48 hours, 90% chance next 5 days. This one is expected to slide to the west. If we look at the 5-day graphical, this is the path it's going to take, and it may take it a little bit uncomfortably close to the Windward and Leeward Islands, and even maybe towards the Bahamas. We're not sure yet. And see, even there, we're starting to talk about going too far out with the runs. We're going to stick with what the NHC has, at least for now. We have another disturbance. This may be Invest 93L. 0% chance 48 hours, 40% chance next 5 days. The next two storms on the list are Helene and Isaac. So that is pretty much it for the tropics. I'm going to go live on my Facebook page here in a little bit because there may be some people in a different audience that may want to tune in and find out what the latest is. There's a lot of hype out there, so don't buy into the hype right now. It's not a good idea. Just be aware that we're watching a system. That's what you need to know right now.
All right, thank you for that, Shay. Stephanie Rankin talking about, so I don't need to stock up on my bread and milk just yet, do I? Also, John Mossman was wanting to know about what was behind Florence, and so Shay talked about that. So thanks for everyone who's been tuning in via Facebook and Periscope. We've appreciated your comments and questions. And as Florence gets closer to kind of making a decision of what's going to happen, we will be following it here at the Carolina Weather Group, and who knows, we may even do our own little updates and stuff like that. Jennifer Lynn says she doesn't care what happens as long as Jim Cantore doesn't come to Charleston. So there you go.
Well, it would be timely if he came here and tried to get kneed by another CFC student.
I mean, honestly, I don't think it'd be Cantore I'd be worried about. It'd be Seidel, right?
That's
Agree
true.
on that.
Seidel's always out in the middle of it.
Cantore, that's no good. But if you see Seidel, just turn around and just leave now. Drive north.
That's right. That's right. Well, Shay, we appreciate that. Jen, thank you so much for joining us. Next week, it's we kind of planned it like this, to be honest with you. We're not fortune tellers or anything, but we knew the first 2 weeks of September is normally the peak season of hurricanes. And so next week's topic is actually Mike Boland's going to be joining us from Mike's weather page. Shay's been talking about that page tonight. So Mike will be joining us. I'm sure we're going to be talking about Florence and Helene and possibly Isaac and whoever knows whatever else rolls off the African coast or even maybe into the Gulf. So we'll be talking with Mike next week about hurricanes and tropics, and really no set topic, but I'm sure there's going to be a lot to talk about. So that's next week. And then on the 19th, September 19th, storm anxiety. I know there's blogs and stuff that's been coming out over the past few days about the hurricane hitting a certain place and people really starting to get freaked out. We're going to kind of talk about that with Rick Smith, who is the warning coordinator meteorologist at the National Weather Service in Norman, Oklahoma. He has done extensive research on folks and kind of their anxiety against storms. So Rick will be on talking about that September 19th. And then September 26th, we're going to be talking with Christina Voss from the University of North Carolina. We're going to be talking about the North Carolina King Tide Project as well. So that's what the next 3 or 4 shows looks like here for the Carolina Weather Group. As always, if you have any guests or potential topics that you would like us to talk about, feel free to reach out to us. I know we are down to maybe 2 or 3 shows that have not been booked for the rest of the year. So we're almost booked up for the 2018 season, and we're going to be quickly booking 2019 here in the next few weeks. So if you have any topics or guests you'd like us to bring on, please let us know and we'll reach out to them and get them on the schedule. So with that, if there's nothing else from the panelists, I'll go ahead and close the show off. We appreciate you watching tonight on the Carolina Weather Group. Like Shay said, stay tuned to the National Hurricane Center and those meteorologists that you trust. They'll continue to update. We'll also continue to update throughout the week and weekend about Florence, and we will reconvene here next Wednesday night. And I'm sure by then we'll have a really good idea of what Florence is going to be doing. So we hope you have a great weekend. Stay safe out there, enjoy it, and we'll see you back here next Wednesday night on the Carolina Weather Group.